Okay, Screencast 5, the last screencast in the unit, oligopoly models, and specifically game theory. I love game theory. Alright, so the good news and the bad news. Let's start with the bad news. The bad news about oligopolies, or maybe it's good news for you, is that due to the mutual interdependence of oligopolies, the fact that their decision making is a function not just of what they're thinking about, but what their competitors are thinking about, no single model can really capture how it is that they behave. They're way too complicated for that. Think back to the Titan game. It would be very hard to create one graph of what you would do in any one turn in that game. There's just too many factors to consider. Not just the factors that you have to think about, but for example, when you choose your price, you're thinking about the price that everyone else is charging. And since you don't know exactly what that's going to be from round to round, it'd be very hard to just draw a graph and just point out in that graph exactly what you should do. Well, the good news, no new graphs for oligopolies. So if you got tired of this whole graphical analysis, you'll be happy. There's just no one graph for how oligopolists behave, act, and operate. So instead, we're going to look at two alternative but very closely related models to try to describe how it is that oligopolists actually behave. The first model is called the game theory model, and the second model, which is very closely related to it, is called the price leadership model. Okay, so let's start off with game theory. Now, you could apply game theory to basically any situation where you have a decision to make. And what happens to you is a function not just of your decision, but the decisions that other people are making too. So game theory kind of has an unfortunate name. You might think it involves only games, and it doesn't. It's called game theory because you're kind of playing these strategic mind games against people. Now, it's true that game theory started with an analysis of poker and optimal poker play, which is perhaps why it's called game theory. But it goes far beyond that. It's a way to think about things or think through things in order to maximize your outcome. If you're self-interested, and we assume everyone is, it's a kind of an alternative way of thinking about strategic decisions or strategic situations to come out on top. So it applies to oligopolies because there's a relatively small number of firms, and again, they're mutually interdependent. So when you're basing your price in the Titan game, you can kind of base that price based on what other people are doing because there's only 8 other firms. If you had to make this decision when there were 1,000 other firms, it would be a lot harder to, and game theory is a lot less applicable. Now I should say, and I can't really stress this enough, there are entire courses in game theory that are taught. In fact, there are places that you can actually major in game theory. So we're just going to look at just the very surface of what game theory is. I'm going to teach you what you need to know for the AP exam about game theory, but I want you to know that it goes far beyond any one screencast. You can click around in some of the optional links for this unit to see some applications of game theory. It's been applied to the Cold War and the nuclear standoff between the US and the USSR. You can apply it to scenes from Batman. You can apply it to game shows. I mean, there's no limit to the amount of situations that you could actually apply this to. And I use it personally all the time in my life. All right, so let's talk about game theory dynamics, at least as you're going to see them in AP Economics. Every game theory situation that you're going to see in AP Economics, at least, are going to have the same fundamental dynamics. So let's define some terms. In every game, we're going to see what are called players. You can think of these as the people making the choices or the decisions, people who have a decision to make. In the Titan game, the players would be each of the teams. You're also going to see what are called strategies. You can think of those simply as the choices or decisions that the players have to make. So in the Titan game, the strategies would be what price to charge, what quantity to produce, and etc. The third thing we're going to see in every game theory game is what are called payoffs. And you can think of that as what's going to happen to you under various combinations of choices that you make and the other players make. And finally, in every game theory game, we're going to see something called a payoff matrix, which is kind of like a little chart that summarizes all of this information. Now, depending on the game theory game that we come across, we may or may not see the following things, but we're going to be looking for these things. First thing we're going to be looking for is what's called a dominant strategy. A dominant strategy is a choice that a player can make that will be better than some other choice, regardless of what everyone else does. Now, some games have a dominant strategy, and in some games they don't. The opposite of a dominant strategy is what's called a dominated strategy. And you can just simply think of that as an inferior choice, a choice that will make you worse off no matter what other people do. And finally, we're going to be looking for something called the Nash Equilibrium. Now, this is named after a guy named John Nash, who won a Nobel Prize for game theory. And if you've seen the movie A Beautiful Mind, that movie is about this guy, John Nash. The Nash equilibrium is what is going to happen if each player follows their dominant strategy. So we're only going to see a Nash equilibrium if we can find a dominant strategy. If we can't find dominant strategies, there will be no Nash equilibrium in that particular game. Alright, so let's go through an example. And the example you're going to see is going to look pretty much exactly like any example you're going to see on the AP exam. Again, they all have very common dynamics, at least at this level. Alright, so I want you to imagine an oligopoly with only two firms in the industry. Sometimes that's called a duopoly, duo meaning two, or an oligopoly with two firms. The firms are called Rare Air and Uptown, and let's say that they both sell sneakers. So you have an industry with only two firms in it, and they're both selling sneakers. Each firm is trying to decide whether to charge a high price or a low price for its sneakers. And we're not going to get any more specific than that here. Let's just say that that's its choice, high price or low price. The profits for each firm are going to depend on the price that they're charging as well as the price that the other firm is charging. So here we have a game theory situation, because what happens to the firm is a function not just of the choice that they make, but also of the choice that the other firm is making. So let's take a look at a typical payoff matrix. Every single game theory problem that we see, again, are going to have, first off, players. And we're going to put those players on each side of the matrix. So here's one player, Uptown, and here's another player, Rare Air. Didn't really matter where I put each player, but we're going to put one player on top and one player to the left. Every game theory game has strategies. Again, those are the choices. And in this game, it's whether to pick a high price or a low price. So I'm going to put each of those strategies up here. Here's Rare Air picking a high price and Rare Air picking a low price. Here's Uptown doing the same thing, high price and low price. Every game theory problem has payoffs, and we put those payoffs in the boxes. Now, the way to understand these payoffs is to understand that these are the payoffs that are going to happen under each combination of choices. So for example, if Rare Air picks a high price and Uptown picks a high price, we're going to wind up in this box, and here's what their payoffs are. They're both going to make $12 in profits. Now these numbers I've just made up and thrown in there. Sometimes that's the way you'll see it, and sometimes you'll be given information for you to throw the payoffs in the matrix. In this example, I'm just giving you what the payoffs are, so there was no way for you to come up with these numbers. If Uptown picks a high price and Rare Air picks a low price, we'd be in this box. Uptown would make $6 in profit, and Rare Air would make $15 in profit. So each of these boxes represents the payoffs under every combination of choices. Both of them picking a high price, both of them picking a low price. In this box, Uptown is picking a low price and Rare Air is picking a high price. And in this box, we have the opposite. Uptown picking a high price and Rare Air picking a low price. All of this taken together is what's called the payoff matrix. Alright, so how do you analyze game theory problems? The first thing you're looking for is a dominant strategy if one exists. The way you find a dominant strategy is by putting yourself in the position of each firm and simply asking yourself, what would you do under each combination of choices? So let's start with Uptown. Let's pretend like we're Uptown. And let's say that Rare Air has decided to choose a high price. So I'm blocking out that part of the matrix that we're not talking about, right? If rare air is picking a high price, we must be in one of these two boxes. Here's high price for rare air, so Uptown is either going to pick a high price, in which case we're in this box, or a low price, in which case we're in this box. And if you look closely, or even not that closely, you can see that if rare air chooses a high price, Uptown should go with a low price. If it went with a high price, it would make $12. If it goes with a low price, it'll make $15. That's a better choice. Alright, so if rare air goes high, Uptown will go low. Staying with Uptown for a minute, what if rare air didn't go with a high price? What if they went with a low price? So again, I'm going to block out that part of the matrix that we're not talking about. Now I'm assuming that rare air is picking a low price. Well, if rare air picks a low price and Uptown picks a high price, we're going to be in this box, and Uptown will make $6. If rare air picks a low price and Uptown also picks a low price, we'd be in this bottom box, and Uptown would make $8. So if rare air chooses a low price, you can see that Uptown has a better move. It's to pick a low price again. Now notice something about what just happened. Notice that no matter what rare air does, it always makes sense for Uptown to choose a low price. That is what's called a dominant strategy. A dominant strategy is a choice you can make that's going to be better for you regardless of what the other person does. In this example, Uptown's dominant strategy is to pick a low price. No matter what rare air does, Uptown is better off going with the low price. So we're going to call the low price for Uptown the dominant strategy. Picking a high price would have been the dominated strategy. Alright, now that we played the game from Uptown's perspective, let's play it from rare air's perspective. Okay, so we're rare air now. Let's say that Uptown picks a high price. So I've blocked out that part of the matrix that's not applicable. If Uptown picks a high price, we're going to be in one of these two boxes. If Uptown chooses a high price, rare air should go for a low price. If it goes for a high price, it'll make $12. If it goes for a low price, it'll make $15. That's better. What if Uptown doesn't go for a high price? What if they go for a low price? Well, again, rare air has a choice. Pick a high price and make $6. Pick a low price and make $8. 8's better than 6. So if Uptown chooses a low price, rare air should again choose a low price. Well, again, notice, rare air has a dominant strategy, and that's to go with a low price. Regardless of what Uptown does, rare air has a better payoff if it goes for the low price. So rare air's dominant strategy is also to pick a low price. Okay, so we've identified the dominant strategies. For each of them, it's to pick a low price. Now in this example, they have the same dominant strategy, but that doesn't need to be true. They could have turned out differently if the payoffs were different. So let's talk about the Nash Equilibrium. The Nash Equilibrium is what's going to happen to these firms if they both follow their dominant strategy. And since we assume that people are rational and that they're self-interested, we're also going to assume that people will follow their dominant strategy. So to find the Nash Equilibrium, you simply follow the dominant strategies to the box they lead to, and we call that the Nash Equilibrium. This bottom right box in this matrix is the Nash Equilibrium. In other words, if these people follow their self-interest and are rational, they'll both wind up making $8 worth of profits. It's called an equilibrium because it's a state of balance. We don't need the government to do anything. We don't need to force them to do anything. Self-interest, the invisible hand type force that just leads them to try to maximize their own well-being, is naturally going to lead them to this bottom right box. So the Nash Equilibrium isn't necessarily the best outcome, and it's not the worst outcome. It's simply what's going to happen. That's what equilibrium means. Equilibrium doesn't mean necessarily good or bad. Equilibrium simply means this is the state that things are going to wind up in if people follow their self-interest and try to maximize their own utility and profits. Now you might notice something about this particular Nash Equilibrium. It's not the best box out there. In this Nash Equilibrium, they're both making $8 worth of profits. You'll notice that if they had both chosen a high price, they could have both made more money. So one of the things that oligopolists do, and people in game theory situations might think about doing, is forming a cartel and colluding. Essentially meaning making an agreement, saying to each other, look, if we both follow our dominant strategies, if we both just try to profit maximize, we're going to wind up in this kind of bad place. Why don't we make an agreement, collusion, and act together, a cartel, and both just decide, hey, you pick a high price and I'll pick a high price. Let's move up to that top left box. So let's say they make that deal. You pick a high price, I pick a high price, we'll both make more money. Sounds good, right? It'd be better for both of them, but do you see why this deal likely isn't going to last? Let's say you're uptown, and Rare Air has just pinky sweared with you that they're going to pick a high price. So you know you're going to be in one of these two boxes. There's always a bastard in game theory situations, or almost always a bastard. And in this case, they would probably both wind up being bastards. Because if they both now have this promise that the other person's going to pick a high price, both of them are going to have an incentive to cheat on this deal. If you're uptown and you know Rare Air is picking a high price, you know you're in one of these two boxes. So you can stay with the deal and make $12, or you can cheat on the deal and make $15. Rare Air is going to think the same thing, and that's going to make them also wind up picking a low price too, cheating on the deal. And if they both cheat on the deal and they both pick a low price, we're back to this bottom right box, which is partially why we called it an equilibrium. It's where we're going. It's the state of things. People are bastards. All right, so cartels and collusion. If oligopolists can collude, if they can make those agreements and stick to it, then theoretically that they could collectively just act like a monopolist and split monopolist profits. That's essentially what a cartel is. So this is really the only graph that we're going to see in oligopolies, and it's just really a monopoly graph. Imagine this was a monopolist that was making this green rectangle worth of profits. If instead this was a duopoly, two firms, what they might say to each other is, look, hey, we would maximize profits if we were acting as one if we produced 100 units. So why don't we each produce 50 units and split those profits? You get the green half, I'll get the yellow half. But again, because it's a game theory situation, this might not be a stable outcome, as they both might wind up cheating on that deal. So an example of overt collusion, obvious collusion, might be OPEC, the oil-producing countries. Every year, Saudi Arabia, Venezuela, other countries get together and they make a deal. They say, hey, we're producing a lot of oil. Why don't we cut back our quantity, reduce our production, think about the demand curve, and jack up prices on everyone? So inevitably, every single year, they get together in some Middle Eastern country and they make a deal. Let's all cut back our production and jack up our prices. And then inevitably, what happens is they go back to their own countries and they start cheating on those deals. They say to themselves, hey, if everyone else cuts back their production, but I produce a little bit more, I'll be able to sell it at a higher price and I'll make more profits. But of course they all think that, and that's why we actually don't wind up worrying about OPEC that much, because they all wind up being bastards. It's kind of inevitable. It happens all the time. Now, overt collusion is actually illegal. You're not allowed to do that. The reason the OPEC people get away with it is that they meet in countries outside of our country, and we can't simply apply our laws to them. So as a result of that, sometimes what oligopolists do is what's called tacit collusion, which kind of means hidden or not obvious collusion. Instead of meeting in some country and agreeing on a price, for example, the CEOs of various companies might get together for a round of golf. And they might say to each other, hey, I'm not saying to do this, but I'm just thinking about raising my price. And wouldn't it be cool if we kind of all raised our price? That may be an example of tacit collusion. Now, there are obstacles to collusion, and I've kind of mentioned both. One is the fact that it's illegal, and the second is the fact that firms in these situations tend to cheat on these deals. All right, so let's see how well you do with a game theory problem. I'll give you a relatively simple one and then maybe a different one. Okay, so grab a piece of paper, see if you can create a matrix. Let's say that Nike and Reebok are trying to decide whether to hire a celebrity endorser. Each of them are trying to decide whether to hire a celebrity endorser. The payoff matrix on the next slide shows what happens to each of the firm's profits if they do or don't hire a celebrity endorser. See if you can find each firm's dominant strategy, and then see if you can find the Nash equilibrium. Okay, so here's the payoff matrix. I'm going to strongly suggest you pause the video and play through it. Put yourself in the position of Nike and ask yourself, what would you do if Reebok hires a celebrity endorser? And what would you do if they don't hire a celebrity endorser? And if you would do the same thing either time, Nike has a dominant strategy. The same is true with Reebok. So pause the video, see if you can figure it out. Unpause. Here's the answer. In this game, they both have a dominant strategy, but their dominant strategies are different. Reebok's is to hire one, and Nike's is to not hire one. And if you follow those dominant strategies to the box they lead to, you have the Nash equilibrium, in this case, the bottom left box. Okay, try one more. Let's say that two people decide to play a game of chicken with cars. The game goes like this. They drive straight at each other, and they see which one swerves. And whoever swerves, that's the chicken, the loser of the game. Now to be a little bit more specific about it, let's say that one person swerves and the other one doesn't. The one who swerves loses the game. Let's call that losing 100 utils, units of happiness. The person that doesn't swerve wins the game. Let's say that they get plus 100 utils. Let's say that if neither of them swerve, they both die. Let's call that negative 1,000 utils. Finally, let's say they both swerve. If they both swerve, they're going to feel some shame. They didn't win the game. But they're going to feel not quite as bad as if they were the only one who swerved. So let's say that if they both swerve, they both lose 50 utils of happiness. Alright, again, see if you can construct a payoff matrix and play this game through. Now I'm not going to show this one to you. I'm going to let you think about this one. But if you look at it long enough, you'll see why this is such a stupid game to play, why it's such an unpredictable game to play, why you probably shouldn't play a game of chicken with cars. If this isn't, if you don't get to the result here mentally or having written it down, come on in and we can talk about it. Alright, so that's game theory in a nutshell, and again, I'm hoping to do a lot more game theory in class, show you some of the applications, maybe play some game theory games with you guys, and again, I want you to know that it gets a lot deeper than that, but that's what you're going to see in terms of the AP exam. Very closely related to the game theory model is what's called the price leadership model of oligopolies. You can think of the price leadership model as a kind of tacit collusion, a way of making agreements in these game theory games, but doing it legally, or at least not doing it blatantly illegally. Now, the way the price leadership model works is that typically a dominant firm in the industry, and this happens all the time in the airline industry, for example, will simply lead on the price. The firms can't get together and agree on a price expressly, that would be illegal. So another way of getting at that same result is to have one firm that's kind of known as the price leader. The price leader will make infrequent price changes. They do that as a way to clearly communicate what the price is going to be. If Delta, for example, constantly changed their prices on all sorts of different flights, they wouldn't be a very good price leader. Firms wouldn't really know what the price is supposed to be. Secondly, the firm will communicate that price change in some way. Now, one way might be just to change the price and other people might notice it. Or it could be like the CEO of Delta getting in front of a press conference and saying something like, oh, well, fuel oil prices have gone up, and as a result of that, we're going to have to change our prices and increase them by 10%. It's a way of making an agreement with other firms without being in the same room with them. Now, when the dominant firm picks a price, they're not going to necessarily pick the absolute highest price that they can get away with, because they don't want to make these things too profitable and possibly invite other firms into the industry. So when they raise price, they'll raise it, but only up to a limit. And that's sometimes called limit pricing. They want to make a profit, but not so large a profit that the industry becomes attractive to new competitors. So that's called the price leadership model. You can think of it as kind of like a subset of game theory, a situation where it might be profitable to kind of collude and form a cartel, but kind of in an informal way. All right, so to finish up oligopolies, as you just kind of saw, we're going to talk about the efficiency aspects. Again, how society views things in terms of productive and allocative efficiency. Now, since there's less competition than monopolistic competition, and obviously less competition than perfect competition, we're going to see that oligopolies aren't going to be efficient. The only the only market model that actually turned out to be productively and allocatively efficient was perfect competition. With monopolistic competition, we had lots of competition, but we didn't even have those things. Furthermore, if oligopolists collude and start acting like a monopoly, the societal impacts are going to be just as bad. So I'm not going to go through again what it means to be productively efficient or allocatively efficient. You can go back to the third screencast in this unit or screencast in the previous units to see that. But if they're acting like a monopoly, or even if they're acting with some degree of market power, they're not going to be productively efficient, and they're not going to be allocatively efficient. Again, it's only perfect competition that got us to those outcomes. All right, with that, we wrap up a pretty large chunk of the course. This kind of second part of the course was all about product markets, and we've lived in that little box for a good number of weeks, all the way from perfect competition through oligopolies. When we resume, we're going to jump boxes in that circular flow model out of the product market box and into the resource market box, but we'll leave that for next time.
Stan? Stan?
Hang on, guys. My dad wants something.
Stan!
What?
You've been on your computer all weekend. Shouldn't you go out and socialize with your friends?
I am socializing, Artard. I'm logged on to an MMORPG with people from all over the world and getting XP with my party using TeamSpeak.